While you may already have a development environment set up, I would like to talk to you about some tools that you should be using and some of which you may already be using to set up a proper Python development environment. Python may be one of the easiest programming languages to get started with and to introduce someone to programming through. It is a very versatile language that can be used in everything from building websites to automating tasks and processes to software testing, data processing, visualization, machine learning, deep learning, and data analytics. However, this versatility did not marry well with simplicity when it came to setting up a clean development environment. The world of Python package and environment management is a mess. Hopefully in the next few videos, we'll be able to untangle some of that mess for you and to go on to build a clean and efficient development environment. In doing so, we'll talk about different categories of tools and technologies, we'll understand the different purposes that they serve, and discuss a few alternatives so it's easier for you to pick and choose the tools that would make up the best development environment for you and your needs without having too much bloat around that environment that may be consuming a lot of your computer resources. At a very high level, setting up the right development environment is all about environment reproducibility. Being able to repeat experiments is the foundation of all science, and being able to reproduce your data analysis and your data science experiments is no different. When it comes to development, the libraries and tools that you integrate into your solution would always receive version updates. This may include adding new features, fixing issues and bugs, patching security vulnerabilities, and sometimes removal of features, and so on. When a library that you're using gets updated, the software might be impacted, either positively or negatively. The results and the output of using those libraries may change or sometimes even break. If you're collaborating with a team on the same project, you need to make sure that everybody is using the same environment setup, the same version of the packages, and the same version of Python. Otherwise, what might work for you would break for somebody else. That's why we need to concern ourselves with being able to reconstruct the environment with the correct version of the dependencies and their sub-dependencies and so on and so forth. So let's set an overarching umbrella for what we're going to be talking about here. We'll need to learn about how we download and install third-party packages, and that is package management. Now, the problem here with Python is that when you install a package, it installs it globally for the whole computer. And so all your projects on that computer will be using and sharing the same dependencies. And obviously that's not ideal. Every project will have its own set of dependencies, probably the different versions and so on. And so you'll find yourself needing to delete every dependency that you have on your computer and install them again. So for that, we'll talk about how we can create virtual environments or self-contained environments so that if you're working on multiple projects, every project can have its own set of dependencies. And that's virtual environment management. Finally, because a reproducible environment isn't just about the third-party packages that you install, but it's also the Python version itself, we need to be able to utilize different versions of Python, and that is version management. These three categories of tools is what we'll be talking about to create a reproducible and flexible development environment.